Hello everyone, this is Dr. Lennon, and I wanted to go over three problems from the homework that I received questions on. So the first one, so these are all probability examples. We're looking at a probability distribution function, and well, first we're asked, is it a probability density function? So that means if you integrate the entire domain, your value should come out to 1. And problem number part B of this problem is to figure out the probability that x is less than 2. So you'll just be doing an integral again for that. So basically the main thing is to figure out what the antiderivative of this thing looks like, and then we go from there. So let's go ahead and do that. Let's figure out what does the and again, I'm going to do this first with just no limits, and then part A will apply the limits from 0 to 5, and for part B we'll apply the limits from 0 to 2, and those will give us our respective answers. So we've got 3 over 125 x times, I'm going to rewrite the square root as the 1/2 power, 25 minus x squared to the 1/2 power. And basically to integrate this, the technique we want to use is we want to use a u substitution. So we can let u be equal to 25 minus x squared. So then du will be minus 2x dx, and then usually we like to just solve for dx so that we don't have to worry about rewriting stuff in a particular way. So this integral, we can write it up here as the integral of 3 over 125 x times u to the 1/2 power, and then we are replacing the dx by du over minus 2. So we can bring that constant out in front. Again, this will end up as negative 3 over 250, just multiplying those numbers. And, oh, sorry, it was 2x. But anyway, the x cancels with this x right here. And then we get the integral of u to the 1/2 du. And so we do the antiderivative, so we get negative 3 over 250 times, remember you add 1 to the power and then multiply by the reciprocal when it's a fraction. So when you add 1 to the power, you get 3 over 2. So we're going to be multiplying by 3 over 2/3 times u to the 3 over 2. And that's our antiderivative. So we can simplify that a bit. The 3's cancel, and the 2 will go into 250 125 times. So we get 1 over 125 minus 1 over 125, and it would be u to the 3 over 2. We can either go back to x or switch the limits, just depending. I'm just going to go back to x, I suppose. So we get 25 minus x squared to the 3/2. So this is our antiderivative. So part A, basically, we just take this antiderivative and we want to do the limits from 0 to 5 and make sure that comes out to 1. So we would have minus 125, 25, minus 1 over 125, 25 minus 5 squared, minus, and then again we have the negative 125, so this becomes a plus 1 over 125, and then we're doing 25 minus 0 squared to the 3 over 2. So for part 1, 25 minus 25 becomes 0, so this first part goes away, the first term, and we end up with just 1 over 125, and then we end up with 25 to the 3 over 2, which is 125, so that comes out to 1. So basically that is the reason for part A. Yes, what was the function named? F of x. Yes, f of x is a PDF, probability density function. Okay, so for part B, they want to know the probability that x is less than 2. Well, it's 0 everywhere outside of the 0 from the interval from 0 to 5. So we're just integrating from 0 to 2. So again, basically, we use this expression to evaluate A and B. So in B, again, we're just going to do the same thing there and plug in 0 to 2 instead. So basically our probability is going to be minus 1 over 125 times 25 minus 2 squared plus 1 over 125 times 25 minus 0 squared up to the 3 over 2 power here and to the 3 over 2 power here. So what do we end up with? Well, probably going to have to use the calculator here. So we have, well, basically I could do a little bit more, a few more steps. So we have 1 over 125, and then 25 minus 4 is going to be 21. So we have 21 to the 3 over 2, and then we know this other part just comes out to 125 over 125, so this comes out to 1. So I don't know how many decimal places they ask for, but 21 to the 3 over 2. Sorry, I'm messing this up on my calculator. All right, so there we go. We end up with 0.2301 is what I end up with. So basically that's our probability that x is less than 2. So that's it for A and B there. Again, just figuring out the antiderivative, or using U substitution as the main part of that, and after that, parts A and B are just plugging in the values. Okay, so let's go ahead and look at the next one that I was asked about. So I've taken screenshots of these, so let me just go ahead and insert that. So let me see if I can move this. And maybe resize it. Okay, so the first one, it says for what value of k is f a probability density function? Again, it's equal to 0 if x is less than 0 or bigger than 5. So basically that means this function is only non-zero between 0 and 5. So basically we just have to figure out the antiderivative for a and b. So for a and b, that's going to be the first part. So let's do the antiderivative of k x squared times 5 minus x with respect to x. So one thing you can do is k is a constant, so we can just pull that out of the integral, and we have x squared times 5 minus x. And then since that's a polynomial, we can go ahead and just distribute the x squared. So this will become k times the integral of 5x squared minus x cubed dx. So our antiderivative here is really just k times, well, again, for this, we just need to add 1 to the power and then divide. So we get 5/3 x cubed minus x to the 4th over 4. So basically, again, we use this for A and B. So for A, basically what happens is the region that this function is defined on, the entire domain, is from 0 to 5. So what we're going to do is we're going to, and if for what value is it a probability density function, that means when you evaluate this thing from 0 to 5, it has to equal 1. So we have our expression that we just wrote down. If we go from 0 to 5, this has to equal 1. That's what it would mean for it to be a PDF. So let me just look at that down there. So we have k times 5/3 x cubed minus x to the 4th over 4. So basically we just have to plug both of those things in. And if it helps, the k doesn't matter. So maybe dividing by k first would simplify things for you a little bit. So if we actually just look at 5/3 x cubed minus x to the 4th over 4 and evaluate this from 0 to 5, this has to equal 1 over k. And then we can solve that value for k. Well, one thing that's nice about this is that's all we really have to do is plug in 5, because when we plug in 0, all the other terms are going to go away. So essentially this side is just going to be 5/3 times 5 to the 3rd power minus 5 to the 4th power over 4, and this equals 1 over k. So 5 to the 4th is 625, so we get 625 over 3 minus 625 over 4, so that equals 1 over k. And then let's see, well, let me just simplify that. So I'm going to cheat and just use my calculator here instead of getting a common denominator. But this comes out to 625 over 12, which I should have known because 1/3 minus a 4th is a 12th. So this comes out to 625 over 12. So if 1 over k is 625 over 12, then that means k should be 12 over 625. You just flip it over to find the value of k. So that means 12 over 625 equals k. So this is the answer to part A, 12 over 625. Okay, so for B, we're going to do the same thing. We're going to use this expression, but now it says find the value for P for the probability that X is greater than 7 over 2, which is the same thing as 3.5. So for B, we're essentially going to do the same thing, but we now know the value of K, I suppose. So for that value of K, yeah. So once you know K, we can plug this thing in. So basically now we want to replace K by 12 over 625. And then we want to evaluate 5/3 x cubed minus x to the 4th over 4. And we want to go from the bottom limit, 3.5, which is the same thing as 7 over 2, up to 5. So I don't know how much accuracy they require here or if it comes out very nice, but basically, you know, I kind of just do it all at once. So continuing, we just plug in 5 for x first. So we get 5/3 times 5 to the 3rd minus 5 to the 4th over 4, which we already know is 12 over 625, but anyhow. And then we want to subtract 5/3 times 3.5 to the 3rd minus 3.5 to the 4th over 4. And this number, whatever it comes out to be, is going to be our answer to B. So maybe I'll try to simplify inside the simplify a bit before we do the final answer, just to make sure if you're doing it on your own, you can also get the same answer there. So as I mentioned, this comes out to 625 over 12, the first term, and then we're subtracting. Let's do that second part. So we have 5/3 times 3.5 cubed minus 3.5 to the 4th divided by 4. Okay, so I don't know. This comes out to some giant fraction, so I don't know. Probably they don't expect you to put this in exact form. I'm not exactly sure if they would or not. It doesn't look like it on what I've clipped out. Okay, so let's get an approximation here. So 12 over 625 times quantity 625 over 12 minus the fraction we just got there. So okay, so this comes out, it says exactly to 0.3483. So hopefully that works for part B of this problem. If it doesn't, please let me know and we'll get that sorted out. All right, so for part C here, we want to find the mean of this probability density function. So the mean, remember, you just kind of multiply your original function f of x there by x and then integrate over the domain, so from 0 to 5. So what we want to do here is for the mean, so the mean mu is going to be the integral from 0 to 5, and we know the value of k is 12 over 625. And what was our original function? 5x squared minus x cubed. So I'm looking at this line, so multiply by x for part C, and then find the antiderivative. So that's what we're doing there. So kind of, maybe I'll box this in so we know that these are the instructions for the separate parts. So we have the k out front, and then we're going to be integrating now 5x cubed minus x to the 4th dx. So 5x cubed minus x to the 4th dx. Again, the fact that we have 0 as one of our values here is pretty nice. So this comes out to, oh, wait, I think in front, yeah, no, k is 12 over 625. No, we're okay there. So we have 12 over 625, and then the antiderivative is going to be 5x to the 4th over 4 minus x to the 5th over 5, and we're plugging in 0 and 5. Again, 0 is going to give 0 when you're integrating a polynomial, so we just have 12 over 625, and we just need to plug in 5. So we get 5 times 5 to the 4th over 4 minus 5 to the 5th over 5. And so let's see, that's going to be, well, 5 to the 5th over 4 minus 5 to the 5th over 5. So that should just be, if you do a 4th minus a 5th, that should be 5 over 20 minus 4 over 20. So I think you should just get that 5 to the 5th over 20. So that becomes just 12 over 625 times 5 to the 5th over 20. And if you plug that into the calculator, let me just check that. So we get 12 times 5 to the 5th over this 625 and the 20. That comes out to exactly 3. So the mean of this PDF is 3. So that should be your answer for part C. Okay, so let's do the last one that involves the normal distribution. So probably you've seen the normal distribution in stats. So usually we don't even integrate this. Really, we appeal to calculators because it involves so many parameters. But if you know your data is normally distributed and you know the standard deviation and the mean of your distribution, then you should be able to answer any question about the probability of some event on some continuous interval. So again, let's insert. I have this last one. So the last question. Okay, so let's have a look at this. So let's resize it a bit. So move it over here and then see if we can resize it appropriately. Okay, a little smaller. There we go. Okay, so we have this project that talks about the amount of paper discarded, and we have the mean of 9.4 and the standard deviation of 4.2, and we know it's normally distributed. So basically what's going on here is we have some normal distribution, and we know the middle of it is the mean, which is 9.4, and then we're looking for the area for greater than 12. So we basically want to figure out this area right here on a normal distribution. So basically we know that the mean mu is 9.4. the standard deviation, which is normally lowercase sigma, is 4.2, and then we're trying to compute the probability that x is greater than 12. So I'm just going to show you a website we can use to do that. So the website I like to use is StatTrek. So if you go to StatTrek.com, this is normally how I go to it, and then I go down to the stat tables and choose the normal table, and this is a probability calculator. So the thing is, it always gives you the probability that something is less than a value. So for our example, we have a mean of, I think, 9.4, did we say, and the standard deviation was 4.2. So let's go, let me check that. So we have 9.4 and 4.2, and we're looking for the probability that x is less than 12. So the thing is, it says the probability of z less than or equal to z. That's going to tell you the probability always that z is less than 12. So if we calculate, we get 0.732. So if we go back, what it's doing is it's not telling us the area that we want to know. Instead, it's telling us the complementary area. So when we use that calculator, it's saying, okay, well, we know your probability looks like this, and it's saying, okay, if you look at the same two values, 9.4 and 12, what that calculator told us is it told us that this area over here is 0.732. So to figure out the area we want to the right, the probability greater than, we know the area below the entire curve is 1, so we can just do 1 minus 0.732. And we know that comes out to 0.368, I think. 0.268, sorry. 0.268. So if they ask for it as a percentage, you need to make sure to adjust, because this is as a decimal. So 0.268. If they ask for it as a percentage, we would say the answer is 26.8%. So there's a 26.8% chance that a household's throwing away more than 12 pounds of paper, according to this data. So yeah, they do ask for it as a percentage, so we want to enter that as 26.8. And like I said, the website is StatTrek, so I recommend that one. So basically, just www.stattrek.com, and on there's a free normal distribution calculator. So hopefully that answers your questions for homework number 6. We will begin with the multivariable stuff next time, so that will be interesting, and that will be the last chapter that we will be going over for the sequence. So this is Dr. Lennon signing off.